Hey everyone, nice to see you guys all in here. So for today's class, we will discuss Hume's problem of induction. So just so you guys know, the way I'm going to be running these lectures is I'll have the lectures that I'm recording on YouTube Live and I'll write on the board as we kind of talk through some of the philosophical issues and implications. But also, I will post slides that I've made as well for those of you who work better with slides. So I'm kind of doing a hybrid of both slides as well as writing on the board. So hopefully that works out for everyone. Now, in the last lecture, as you noticed, it was kind of a long lecture on the basics of logic. And one interesting kind of general fact that we started with is that all information that you're confronted with when it comes to any class you ever take, whether it's a science class or a math class or any class at all, you're always confronted with arguments. And so this just begs the question, like, what is an argument? Now, informally, right, we think of arguments as maybe like a disagreement between people or has kind of this like negative connotation. But in school and in logic, arguments actually have a very specific meaning. And so if you think back to the last video, maybe you can pause right now and just try to remember, what is an argument? Well, an argument is a set of sentences where one sentence is the conclusion and the other sentences serve as the premises that support the conclusion. So for every argument, there's always one conclusion, okay? And now all the other sentences within the argument are what we call the premises. What are premises? They're just the reasons, right? They're the evidence for why you should take the conclusion to be true. Okay, good. Now a little more review. Last class, we also discussed the distinction between inductive and deductive arguments. Now, this class will focus on inductive arguments because remember, this is philosophy of science. So let's just kind of review a little bit, though, about the distinction, just so it's clear, like, what these two types of arguments are. I'm just trying to make sure that's right. So you have these general categories of things that we call arguments, which really are just how we present any type of piece of information. So it's always presented in the structure called an argument, which is just a set of sentences where one is the conclusion. So one of the sentences is what you're trying to convince the person of, and the other sentences are the reasons or the evidence that serve to support the conclusion. Now, arguments can be divided into two categories. There are deductive arguments, and there are inductive arguments. Okay. Get that on. Now, when it comes to deductive arguments, okay, I'm going to write this out first and then explain as I write it out. A deductive argument can be valid or invalid. Okay. And now a valid argument can be sound. I'm sure you guys can look at that. Actually, this is a better way to do it. Yeah, it could be sound or unsound. We don't have to worry too much about this side, since again, this is philosophy of science. And as I mentioned earlier, science is in the business of generating inductive arguments for the most part, okay? Now, where do we see purely deductive arguments? Purely deductive arguments are found in areas like pure mathematics, geometry, and pure logic. right? So here would be an example of a deductively valid argument that's also sound. So just like a good deductive argument. I think all humans are mortal. Alicia is a human. Therefore, Alicia is mortal. Okay, so in a deductive argument, notice these are the premises, this is the conclusion. So this is standard form as we talked about last class, where you write each premise alone on the line, followed by a line and then the conclusion. Now, notice when it comes to deductive arguments that are valid, and in this case sound, the truth of the premises necessitate the truth of the conclusion. In other words, it's impossible. It would be impossible for these two premises to be true and this to be false. If it is true that all humans are mortal, and I am a human, which is true, then this just has to follow with complete certainty. With complete certainty. You see what I mean? So maybe if you think back to your geometry classes, that's where we did a lot of deductive reasoning. You think to yourself, you know, uh, all objects with four right angles are considered a rectangle. A square has four right angles, and so a square is a certain type of rectangle. We did this proof in Euclidean geometry. So this is all to mention that, like with deductive arguments, the truth of the premises or the reasons or the evidence establishes the truth of the conclusion with complete certainty. And that's why we usually see pure deduction in these more kind of formal areas of reasoning, like pure mathematics and pure logic. Okay? Now, erase that. Because really what we're interested in this class is induction, because induction is what we usually use in science. Now, when it comes to inductive arguments, as we were discussing last class, I don't want to review too much. Inductive arguments can be strong or weak. So unlike deductive arguments where either the truth of the premises make the conclusion true or make the conclusion false, with inductive arguments, the truth of the premises either make the conclusion more or less likely to be true. Okay? More or less likely to be true. So and this will be in the slides I send as well, so you'll have all this resources. In inductive arguments, the truth of the premises do not guarantee with certainty, not with certainty, the truth of the conclusion. Instead, a good inductive argument is what we call inductively strong. And it's where the truth of the premises establishes the very high likelihood of the truth of the conclusion. So, I've watched the sunrise every morning for the past 5,000 days. Therefore, it's very likely that tomorrow morning when I wake up, I will watch the sunrise. That's an inductively strong argument. Okay. Now, an inductively weak argument, a bad inductive argument, is one where the truth of the premises do not establish with any likelihood the truth of the conclusion. So something like, I wore a red shirt to my last final and got an A, therefore the next time I wear a red shirt to my final, I will also get an A. That's inductively weak. Why? So now let's think of the difference between these two cases. Well, notice in this observing the sunrise case, we're doing this, I said 5,000 times. The number of observations is quite high. In the test-taking case, notice that the number of observations is just one. So just because one time you wore a red shirt and got an A on your exam does not establish any kind of sustained connection between wearing the color red and getting an A, okay? Okay, so that's just a little review. Let's keep moving along. Let's see. So I want to talk a little bit about, a little more about inductive arguments. So first, what do we notice? Inductive arguments. So induction, this form of reasoning called induction, is often used in science, is always used in science. So this type of reasoning called induction is always used in science. That's kind of interesting. Because now really think about it, what are we doing in science? What we do normally is we observe something, some pattern, right? Some correlation, right? Some kind of correlation between two things or some kind of causal relationship between two things. And we observe it over and over and over and over again until finally we either make a generalization that these two things must be correlated or causally connected, or we make some kind of prediction about the future that given all these observations, it's very likely that the same pattern will continue to hold. So science is all about observing the world and finding patterns, finding structure to the world. Okay? So now let me write some of this down. Maybe that'll be helpful. Now, and I'll read this out loud as I'm maybe writing. So inductive arguments usually take the form of observation statements. So a set of observations. You're observing something in the world over and over again. And those are your premises. And then the conclusion is sometimes a generalization based on those observations or a prediction about the future. Okay? So now let me make that crystal clear with an example. Okay, so let's say that these are my observations. So let's pretend I'm a psychiatrist, okay? And let's pretend I've observed 500,000 patients. So of the 500,000 patients, I have observed each Okay, so here's an example. Let me just make it so you guys can see it better. There we go. Okay, so here's my inductive argument of, let's pretend I'm a psychiatrist and I'm doing a study. And I notice this. Of the 500,000 patients that I have observed, each of these patients who has low serotonin, that's just a neurotransmitter, has a low serotonin level, each of them also has depression. Let's just pretend. Okay, so I observe patient 1, 2, 3, all the way to 500,000. And I look at their kind of neurochemistry and I notice that each of them has low serotonin. And I also know or notice that each of those 500,000 patients has depression. Here, based on this evidence, the premises here, based on all these observations I've made of 500,000 patients, I can come to this conclusion as a scientist, this inductive conclusion. It is very likely that depression is somehow correlated with having low serotonin levels. There seems to be some kind of common generalization I can make between having low serotonin levels and this phenomenon of depression based on all these observations I've made of patients who have low serotonin and also have depression. These two things, I mean, 500,000, we can even imagine this number is 5 million times. I mean, the amount of observations gives me the stronger evidence to come to the conclusion that these two things are related, depression and low serotonin. Okay? So here's one, I'm giving this example because notice in science, one way in which we use induction is by observing some systematic pattern, observing some kind of correlation over and over and over and over and over again in the world, and then coming to the conclusion that this correlation must be true. Like it must be the case that these two things actually correlate, that they have something to do with each other. Otherwise, why would I observe it so many times? You see what I mean? Okay. But science isn't just about coming up with general facts. Science is also in the business of making predictions, right? We care a lot about using our scientific knowledge to make predictions about the future. And so now I'm going to erase this and give another example to make that clear. Okay. So again, as we mentioned, inductive arguments, they take this form where you have a set of premises or reasons or evidence. They're usually like observations the scientists made. And from that, you can come to some generalized claim. Or from that, as I'm going to show right now, you can come to some prediction about the future. So let's do another example. One where now we're using induction to make a prediction. Let's say this. The past 500, let's do 5,000. 5,000 out of 5,000. 5,001 times. When I open the faucet, water comes out. Okay. So suppose for whatever reason, I don't know, I'm a nerd and I notice, okay, for the past 5,001 times in the morning when I turn on the faucet to brush my teeth, 5,000 of those times water has come out. Only one time the water didn't come out. But all the other times it did, let's just say. Okay, so all I'm just showing here is like, okay, 5,000 times when I've turned the faucet in the morning to brush my teeth, water comes out. From this evidence, this premise, these observations I've made, this 5,001 number of observations, I can now come to predict something as a scientist. And what can I predict? That it's very likely, it is very likely that when I open the faucet, let's say tomorrow morning, water will come out. Okay, sorry for the messy writing. So here's my conclusion. Notice the conclusion here is predictive. Sorry. So unlike the one with the psychiatrist and the serotonin where the conclusion is a generalization, all I'm pointing out here is induction also helps us make predictions about the future. Because now notice, if we didn't use induction, if we didn't look at observations and patterns in the world to predict things about the future, I mean, we would be pretty lost. So this is, I know, a silly example, but because I've observed 5,000 times, when I've opened the faucet, water has come out, it is very likely that tomorrow morning, when I wake up and I'm getting ready to brush my teeth and I twirl the faucet, it's very, very likely that water will come out, right? It's in fact, you know, like over 99% likely, okay? So this is just to kind of illustrate that inductive arguments, they're used in science. And how so? We make observations about the world, we come to generalizations. We make observations about the world, we come to predictions about future states. And that is how inductive logic works. Okay? So far, so good. I'll give you guys more resources too, and slides and stuff, to make this clear, but let's keep going on. Now, we've talked a lot about induction in this class already, and we've talked a lot about logic. And you might be thinking, why are we talking about this stuff? Because this class is philosophy of science. Well, I always set it up this way because the first thing I'd take note is science really is a form of human reasoning. It's a way in which us human beings kind of evolved to make sense of the world. And so logic, notice, is a big aspect of how us humans have been able to do so many marvelous things, like build technology, put a man on the moon, learn and discover about so many features of reality, do so many interesting things with mathematics. And so that's why I like to start with this kind of introduction just to the basics of logic. But now you might be wondering, okay, we've talked a lot about induction. I see, Professor K, how it relates to science. But when we talk about science, I mean, what are we really talking about there? What is science? I'm throwing this word around. And I assume everyone has a sense of what science is, of course, but how would you come to define it? So maybe this could be a place where you could pause the video and you can, think to yourself, how would I define this word called science? We use it all the time. What exactly does it mean? Okay. Well, I'm going to turn this a little bit towards me. Hopefully you pause the video and thought to yourself, but I'm going to now say some kind of ways in which we can define what science is. I won't write this down because this is also in the slides and in the notes I'm going to send you. But science, you can think of it as, again, like a method of inquiry. And it's a type of reasoning. That's why we're talking so much about logic. And it's a type of reasoning where you move from something observable, some measurable fact in the world, to a testable explanation for those facts. So the task of the scientist is to discover, is to observe, is to collect facts in a systematic way such that they can kind of see patterns in the world, explain relations among things, why things work the way they work. And so this is why science is predicated on inductive logic, right? It's all about making observations about the world and then coming to some generalizations based on those observations, or making predictions based on those observations. Okay, and so for this reason, we say that science, let me go back to a better view of the board. Science is empirical. It's empirical. Now you might be like, well, what does that mean? Empiricism. So, in the history of human knowledge and in the history of science, and this is something we'll talk about more in the upcoming lectures when we actually talk about the history of science. There's big debates about how human beings come to know things. Do we come to know things through observation? Do we come to know things just through like thinking, in our minds and reasoning about things? Is it a mixture of both? So empiricism was thought to be empiricism is a method of inquiry where knowledge is obtained from our five senses. Okay, so I'm going to write that down. Okay, so empiricism, a method of inquiry where we derive knowledge. So we actually get knowledge about the world. We get facts about the world. We come to know things about the world through observation. And the reason why I write five senses here in parentheses is notice the only way we can observe things is through our senses, right? Through seeing things, through touch, through smell, right? So empiricism is this kind of philosophical commitment that, like, yes, we actually can come to discover facts about the world by observing things in the world, just in a systematic way. And now, hopefully, you notice that, yes, science is empirical. That's kind of the whole point. We can learn about the world, we can learn about patterns in the world by observation. Okay, cool. Now, let me see. Yeah. Okay, so we'll get more into this as well when we start talking about the history of science, because believe it or not, like this thing called science is actually quite a recent form of inquiry when you look at human history. So there's a lot of debate on like what it even is and how we use it, and et cetera, et cetera. So one thing I want to point out to you is that as science kind of took off in the Enlightenment period as like a legitimate form of learning about the world, there were certain assumptions we had to just make, like certain starting premises, starting assumptions. You can think of almost it like, when I say starting assumptions, like the axioms in math. In math, you have just these things called axioms that you just take to be true, right? You just assume it to be true. You can't even really question whether it's true or not, because if you do, you'll run into some puzzles. There's the same thing holds for science. There are these like kind of starting assumptions that all scientists agree to, because otherwise, if we did not have these starting assumptions, we would not be able to do science at all in the first place. Okay, now one of the assumptions is empiricism, that we can actually get knowledge about the world through observation. Okay, another assumption in science, I'll put it up here, is that science, so make sure you guys, yeah, can see. So science concerns an orderly and predictable universe. So, in other words, here's an assumption behind science. Here is something every single scientist assumes. They assume it because why? They can never establish it as a fact. Okay, so it's an assumption. And what is the assumption? That our universe is orderly and predictable. We just assume that. So this is quite interesting. We just assume that we live in an orderly and predictable universe. What do I mean by that? What I mean by that is if there is some pattern I'm noticing, and I keep noticing that pattern over and over and over again, then in all likelihood, that pattern will continue to hold. So if I keep, seeing Steph Curry make his free throws, 97% of the time, for all practical purposes, I could bet that that pattern will continue to hold. Or if I notice that, of all the cats I've observed, thousands and thousands, they all have a carnivorous diet, that, yeah, the next cat I see tomorrow, it probably similarly will have a carnivorous diet, okay? Now notice these types of inferences can only make sense if we assume that the world or the universe is orderly and predictable. Okay, so sorry. So let me say a little bit more about this assumption that the universe is orderly and predictable. Again, scientists assume this, that the universe is orderly and predictable, such that causal laws, correlations, they will continue to hold, and inductively strong arguments are justified. Okay? The orderliness of the universe allows me to make justifiable inferences about the future because I can safely assume that the future, for all practical purposes, will be like the past. Now, this is important because remember in our last lecture, we're talking about the difference between induction and deduction. With induction, the truth of the premises, so in science, like the truth of the observations establishes the high likelihood of the conclusion, right? So the fact that I've seen the sunrise every morning for the past 5,000 times makes it 99.9% likely I'll see it again tomorrow rise. It doesn't establish it with complete certainty, though. I'm not 100% sure. Why? Because for who knows? For all I know, the sun will explode tomorrow, or the earth will explode, or maybe I won't wake up, right? So I'm not 100% sure, but I'm almost 100% sure. I'm very, very sure. Okay? Now, this type of reasoning that we're discussing, notice it kind of rests on this assumption that we do live in an orderly and predictable universe, that we can safely assume for all practical purposes, the future will likely be like the past. Like, so today, tomorrow, things will likely be like how they are today. In other words, let's say I drop this pen and I keep dropping it and I drop it 5 million times. And each time I watch it hit the table. Okay? Based on the fact that I've done this, let's say now 5 million times, because I live in an orderly and predictable universe, I can safely assume that the next time I drop this pen, it will again fall, hit the desk, and won't just randomly turn into a chicken or randomly float away. Okay? So there's something patterned, there's something organized about the universe we live in. It's not just like one day I'm going to start drinking this water and it's going to turn to gold, or one day I'm just going to wake up and my hair is going to be purple for no reason. Things don't just change randomly, right? That's not the type of universe It's not how we assume the universe to be. Okay, that's what this assumption means. But now let me just pause here for a second. Notice, notice that this is, I keep calling it an assumption. What's an assumption? How is this assumption different from a fact? A fact is something you can establish with evidence, right? Like a conclusion, a scientific fact, right? You can establish with evidence. Assumptions, you cannot establish with evidence. There's no evidence to establish the truth of an assumption. So I can assume that all dogs are mean. That's an assumption. Why? Because I have no evidence for that. I'm just kind of like assuming it. I'm just kind of making it up, right? Like it just seems, maybe it just seems right to me that all dogs are mean for whatever reason. And I'm pointing this out because notice that we have to assume. It's not that we can prove this. We can't prove that we live in an orderly and predictable universe. We have to straight up assume it. And now to kind of show why we have to assume it, we're going to talk about Hume's problem of induction. Okay? So all of this just to get to the problem of induction. So I'm going to erase this now. Okay. So I'll put the problem of induction. Okay. So a little bit about David Hume. He's a very famous philosopher, Scottish philosopher. He was kind of working in, or like I guess he lived from 1711 to 1776, which was during the Enlightenment era and during the Scientific Revolution. So you can kind of see he's thinking a lot about science. And he writes this book called Induction, from an inquiry of concerning human understanding, where he tries to kind of analyze like, how do we get knowledge about the world? How does this science stuff work? How does this induction stuff work, etc. Okay. Now let me see. Okay. In the slides, I included quotes from Hume's actual article, and I kind of like broke down the language he uses to generate the argument, or generate the problem of induction, just so that when you're doing the reading, you can kind of make sense of his terminology. Now for the video, I'm going to kind of skip that part of the slides just because it'll take a lot of time, and also I just want to get to the heart of what the problem is. So, if you are a little bit confused about his terminology, feel free to look at the slides I post on Canvas, and that will help you kind of suss out, the types of language that he's using. Okay, but now let's get to the heart of the problem. As I just mentioned, in science, we assume. We don't just assume, we brutally assume. When I say brutally, I mean like without any evidence. We just, it's like a faith. I have faith. We have faith that inductive arguments, or induction, this method of reasoning, provides knowledge about the world. In other words, we just have faith. We brutally assume that inductive reasoning, this thing where we observe some pattern in the world and claim that it's, a general fact, or we observe some pattern in the world and claim that it'll continue to hold. This is something we brutally assume. It's just we have faith that this is that induction works. And now the question is why? Why do we just brutally assume induction works? Why can't I prove it? So why can't I give an argument for the reliability of induction? in science? Why can't I give an argument for why, yeah, the more times I observe, let's say, I don't know, someone with low serotonin and having depression, the more evidence and the more likely it is just an established fact? Or why can't I, just, why do I have to assume? Why can't I just say as a matter of fact, the, the more times I see two hydrogen and one oxygen molecule combined to formulate water, let's say I observed this 50 billion times, why can't I just say that that's a fact? Like, why do I have to say that it's very likely, but I don't know for sure? Okay. And the reason why is because of Hume's problem of induction. Okay. Now, the problem is this: we can never establish that induction is actually a reliable way to get at knowledge about the world. Okay? So we have to just brutally assume that we live in an organized universe, that we live in a universe that's predictable. But we will never be able to prove this. And why can't we prove it? Why can't we give an argument for the reliability of induction? Well, because it results in a circular argument. It results in this puzzle. So now let me write this down. Here's Hume's problem of induction. We cannot, let me say it first and then I'll write it. We cannot justify the reliability of induction without using induction itself. And what this means is we cannot give a non-circular argument for why induction is a reliable form of inference. Okay, so I'm going to write this down. So the problem of induction, we cannot justify Okay. Make sure you guys. Okay, so we cannot justify the reliability of induction using induction itself. We cannot give a non-circular argument for the reliability of induction. So maybe the best way to kind of think about this is through an example. Okay, so let's say that let's go back to the sun rising case. Let's say for whatever nerdy reason, for the past, 50, I don't know, 5,000 mornings, I've woken up at 5 a.m. and I've watched the sunrise. Woke up at 5 a.m., watched the sunrise. And I've done this 5,000 times. Okay. Now I use induction to come to the conclusion that it's very likely tomorrow morning, Tuesday, is tomorrow the 1st? So tomorrow morning on Tuesday at 5 a.m., when I wake up, I will see the sunrise. I'm like 99.999999999999999% sure. Okay? So far, so good. But now, notice, I don't know this for certain, as we mentioned before, I could wake up and first of all, I can never wake up tomorrow morning. Or I could wake up and the sun has exploded. Or I could wake up and now the Earth is off its planetary orbit and it's somewhere off, somewhere else in space. I don't know, right? I don't know with 100% likelihood that tomorrow when I wake up in the morning, I will in fact see the sunrise. All I have is just these past observations that provide evidence for the fact that it's very likely that, given I've observed it 5,000 times, that the 5,001 time when I wake up at 5 a.m., I will once again watch the sunrise. Okay? But now notice the problem here. When you really ask, how do I know? How am I 99.999% sure that the sun will rise tomorrow? Let's say you ask me that. You're like, how do you really know that, Professor? Like, how are you 99% sure that the sun is going to rise tomorrow? What am I going to say in response? I'm going to say, well, because the past 5,000 mornings when I woke up, I saw the sunrise. Okay. But now notice, that's just induction. So when I give you this answer, what you can tell me once again is, yes, I understand, Professor Cosson, that the past 5,000 times when you woke up in the morning, you saw the sunrise. But that doesn't establish that it's going to rise tomorrow morning. So why are you 99% sure that it will rise again tomorrow morning? And now, okay, I'm thinking about it, and now I'm getting a little bit smart. And this is what I'm going to say in response to you. I'll say something like this. Well, look, let's say you asked me this question yesterday. Let's pretend. I'll be like, look, remember when you asked me the same question yesterday? You're like, Professor, how do you know that the sun will rise on Monday, June 30th? How do you know it's going to rise this morning? You asked me this yesterday. And I say the same thing. I say, because look, all the past times where I made this observation, when I woke up at 5 a.m., I did in fact see the sunrise. Okay, that would be the argument I gave you yesterday. And then again, yesterday I wake up and I watch the sunrise. Now notice the problem here. The problem is that I'm using induction to justify the reliability of induction. So what I'm telling you really is, the reason why I think tomorrow morning the sun will rise is because for all the past moments in my life, this kind of method of reasoning called induction has worked. And therefore it should likely work again today and tomorrow. But what we're asking in the first place is, why assume induction works itself? And so now notice, there's no way to justify the reliability of this reasoning process we call induction without using induction. If I try to, I'm just going to go back to using an inductive argument. So again, you're like, Professor, how are you so sure that when two hydrogen and one oxygen molecule combine, they form water, or H2O? And I'm like, well, oh my gosh, look at the hundreds and hundreds of years that scientists have been observing this, right? And now imagine, every time someone asked that scientist the same question, they would point to all the past scientists that made the same exact observation, correct? But now notice, when the scientist gives this argument, all they're saying really is that induction works. They're like, oh, I know tomorrow when I combine two hydrogen and one oxygen molecule, I'll get water because I've observed it every time in the past. Because every time in the past, when I used induction, it worked. But the question we're asking in the first place is, why and how does induction work? Why is it the case that because we observe something so many times, some patterns so many times, that we can safely assume it'll happen again? I mean, we don't know for sure. That's the first problem. I don't know for sure the sun is going to rise tomorrow. And when I really try to justify why I think I'm so sure that the sun will rise tomorrow, that I'm 99% sure that it will, the only thing I can rely on is this idea that induction works. But now, if someone starts to press you and ask you, well, why does induction work? You can't just say induction works because it's always worked. That is a circular argument. That is not a good argument. It's like saying capital punishment is wrong because it is wrong for the state to take the life of a person for committing a crime. That's not an argument. It's circular. You see what I mean? Capital punishment just is when the state takes a person's life for a crime they committed. And now notice we're justifying the reliability of induction by using induction. And that is a circular argument. Because again, the whole point of the question is to generate new independent evidence that illustrates to us that induction is this reliable method of reasoning. And so this is Hume's problem of induction. Okay, so again, this is going to be in the slides, but I like to kind of write on the board too. So let me maybe kind of just read some of this to you. So let's see. So in other words, going back to like this assumption, remember I told you we have to brutally assume, like almost just have pure faith that the universe is orderly and predictable. This is what Hume in the reading calls the uniformity principle. So in other words, what justifies the inference we make, the inferential move from the premises of an inductive argument to the conclusion? How do we make this move? It's just the fact that up until now, the future has always ended up conforming to the past. So again, like why am I 99% sure the sun will rise tomorrow morning? Because what I'm going to say is relative to every single point in the past, every single time you've asked me this question in the past, let's say, relative to every single point in time, what did I notice? I noticed the next day that the sun did in fact rise up until now. But notice that's just induction. How do we know for sure that tomorrow will be like today? We don't. And that's the problem. And the only argument you can give for why you're 99% sure the sun will rise tomorrow is because you've observed it so many times in the past. But that does not help us with this question of why assume the future will be just like the past. We don't know that with certainty. And so therefore we brutally assume, almost like it's a matter of faith. We just have faith that the future will be like the present or past. That, tomorrow, just like right now, when I drop this pen, it's going to fall and hit the table and not randomly turn into a chicken. I just have to assume that about the future because, of course, I don't know that the future will be like the past. And notice now the problem of induction illustrates we can't even give an argument for why we should assume the future will be like the past, because any argument we try to give is an inductive one, which thus results in a circular argument. So how trippy and weird is that? Induction, literally, science, like the most reliable method of inquiry probably us human beings have come up with, is predicated on this form of reasoning called induction that we don't even know how and why it works. That is very strange. It's a strange problem. Okay, so the rest of this, I'm gonna have it, they're all written in the slides. I don't wanna, part of what I'm doing here is not to make the lecture videos too long because I just feel like how can someone concentrate? I mean, this class is supposed to be 3 hours. and I just don't understand how a person can concentrate for that long. So here is, me talking through the problem of induction. I will send you the slides so you can read through them as you listen to this video. And in the next video, we'll talk about Goodman's new riddle of induction. Okay? Thanks, guys, and I will see you soon.